Teacher Mamu. Today I will teach you about mathematics, which is about linear equations and inequalities. Okay, in our previous lesson, we have seen different topics on the third unit. So today we will see the fourth topic on third unit, which is about applications of linear equations and inequalities. Okay, so 3.4 is about applications of linear equations and inequalities. As you remember, in our previous lesson, we have seen different things such as locating a point on a Cartesian coordinate system. The other thing, we have also seen how to sketch the graph of a linear function using different methods. Then after, we have seen how to find the solution for a linear inequalities. Okay, those 3 points were our previous point of discussion. So today we will have a discussion on applications of linear equations and inequalities. Okay, so in our day-to-day life activity, we apply the concept of linear equations and inequalities in different occasions. Okay, so to explain this thing, I will take a certain known real-life applications on linear equations. Well, in your science lesson, you have learned about the relationship between the temperature reading in Celsius scale and Fahrenheit scale. And these two variables are related using the formula C is equal to 5/9 times F minus 32. Okay, here, this symbol C is a symbol that we use to represent the temperature reading in Celsius scale, and F represents the temperature reading in Fahrenheit scale. And these two variables are related using this formula, okay? C is equal to 5/9 times F minus 32. So clearly, as you can see in this equation, there is a linear relationship between these two variables, right? So now, let's see a certain example regarding this issue. The first example is example 1. Express F in terms of C. Okay. The other thing is what will be the range of C if F is greater than 50. Okay, in this first example, we are asked to express F in terms of C, where F represents the temperature reading in Fahrenheit scale, and C represents the temperature in centigrade, in Celsius scale. Okay, so to answer the first part of this example, we need to take this formula and rewrite the equation to express F in terms of C. So this is how we express this thing. Okay, so the answer for the first part of this example is we already have C is equal to 5/9 times F minus 32. Okay, our objective here is to express f in terms of c, or solving for f gives us a certain expression in terms of c. So now we need to multiply this equation both sides by 9 to avoid the fraction. So this becomes 9 times c is equal to 9 times 5 over 9 times f minus 32. Okay, now multiply 9 by 5, it becomes 45, and divide it by 9, the result becomes 5. Or you can directly cancel 9 by 9. So this becomes 9c. 9c is equal to 5 into f minus 32. Okay? The next step that we need to follow is we have to distribute this number 5 and avoid the bracket. So this gives us 9c is equal to 5f minus 5 times 32 is 160. Okay? Now add both sides 160. Okay, when we add 160 on both sides, the equation becomes 9c plus 160 is equal to 5f minus 160 plus 160. Okay, so here on the right side we have only 5f. Then this becomes 5f is equal to 9c plus 160. Okay, now to obtain f value, you can divide both sides by 5. Then this becomes f is equal to, dividing both sides by 5 gives us f is equal to 9c plus 160 over 5. Or f can be written as 9c over 5 plus 32, because 160 by 5 is 32. So this is the required answer for the first part of example 1. So in example 1, we are asked to express f in terms of c, right? So here we are able to express f in terms of c. So this is the answer for A part. The other thing that we have here is we are asked to find the range of, or the possible value of c whenever f is greater than 50. Meaning, what will be the temperature reading in Celsius scale whenever the temperature reading is greater than 50? So to answer this thing, we need to consider f is equals to 9c over 5 plus 32. Okay? So let's see how it works. The B part, in B part, we are asked the condition or the range of c whenever f is greater than 50. Okay, from A part, we know that f is 9 over 5 c plus 32. Okay, we know this relationship. Okay, so whenever f is greater than 50 means f is greater than 50 implies 9 over 5c plus 32 is greater than 50. Okay? So to answer the question on B part, you need to be able to find the solution for this linear inequality. Okay, if you remember in our previous lesson, we have seen how we can find the solution for any linear inequality. You need to remember all those rules that we could apply to find the solution for a linear inequality. So here we can subtract the same amount of number on both sides, or as usual, simply you can take plus 32 to the right and obtain this thing, okay? So 9 over 5c is greater than 50 minus 32, okay? This happens by subtracting the same amount of number on both sides, right? Don't forget, adding or subtracting the same amount of number on both sides of the inequality cannot change the position of the inequality. So this implies this one. So this means 9 over 5c is greater than 18, okay? So whenever we have this, if you see the coefficient of c, it's 9 over 5, which is positive. So you can multiply both sides by a certain positive number, and the inequality remains the same. So multiply both sides by 5. 5 times 9 over 5 times c is greater than 5 times 18. Okay, now this can be written as 9c greater than 5 times 18. Okay, you don't need to multiply 5 by 18 because you will have some other simplifications. So I want to write it 5 times 18, or if you want, you can make it 90. Okay, for the time being, let me write it as it is, 5 times 18. So the next step will be dividing both sides by positive 9. Okay, whenever we divide both sides by positive 9, the position of the inequality remains unchanged. Okay, so this becomes c is greater than 5 times 18 over 9. Okay, now you can simplify this number. Okay, by 9 1 by 9 2. So this implies c becomes 10. I mean, c becomes greater than 10. So when we come back to the second part of the question, here we are asked to find the range of values of c whenever f is greater than 50. Okay, when the temperature scale in Fahrenheit is bigger than 50, the temperature scale in Celsius scale will be bigger than 10. Okay, this is how we solve these kind of problems. Okay, now let's see another word problems leading to linear equations and linear inequalities. So let's see a certain word problem. Let me change the example. In the second example, let's take a certain word problem. The age of a man and his wife, okay, the sum, okay, make it the sum, okay, the sum of the age of a man and his wife is 64, okay. The sum of the age of a man and his wife is 64 if the man is 4 years older than his wife. What is the current or the present age of the man and his wife? Okay, so in this second example, there is a word problem leading to linear equations. Okay, from this word problem, we may extract two or more linear equation so that we can find the solution for the required thing. Okay, to find the solution for this word problem, you need to have a good understanding of converting a word problem into mathematical expression or mathematical equation. Okay, that is the biggest step in solving this kind of word problem. Okay, the first thing we need to understand the word problem. Then after, we need to be able to convert this word problem into mathematical expressions or into mathematical equations. Okay, that is very, very important and the crucial step to find the solution for the question. Okay, so in this word problem, there are two variables. Those variables are the age of a man and the age of his wife. Okay, you need to represent these two variables by something. Okay, so let's say let the age of the man is say M. Assume this is the present age. Okay, currently, if the age of the man is M, let's say again, let's say the age of his wife is W. Okay, now we have two variables, M and W, representing the present age of the man and the present age of his wife. Okay, if we set up a variable in this way, the next step is you need to be able to convert this statement into mathematical equations. Here it says the sum of the age of a man and his wife is 64. So based on this representation, M plus W must be 64. Okay, from the first statement, we can extract an equation, M plus W is equal to 64. Okay, we have here one equation containing two unknown variables, right? The next thing is we have another information about the age of this person and his wife. If the man is 4 years older than his wife, okay, look at this statement. If the man is 4 years older than his wife, that means M should be a number greater than 4 by how much? By 4. So M is 4 years older than W. That means M becomes W plus 4. Okay, now we have these two equations. Okay, we have two equations with two unknown variables. So to calculate or to determine the unknown variables, we can use substitution. Okay, how do we use a substitution? Here, M is the same as W plus 4. So in the first equation, you go to the first equation and substitute W plus 4 in place of M. So we get W plus 4 plus W is equal to 64. Okay, now you can collect like terms and calculate the required variables. So we have W plus W. It becomes 2 times W plus 4 is equal to 64. Now subtract both sides 4, or take this plus 4 to the right side and subtract 4 from 64. So this becomes 2 times W is equals to 64 minus 4, which is 60. Okay? 2 times W is 60 means, okay, 2 times W is equals to 60 means dividing both sides by 2, W becomes a certain known number. Okay, divide both sides by 2, then W becomes 60 over 2, which is 30. Okay, this is the value of W, means the present age of his wife is 30. Okay, since the age of his wife is known, from the information that we have here, the age of a man is 4 years older than his wife. So you can substitute here 30 plus 4, then M becomes 34. So M becomes 30 plus 4, which is 34. So the present age of the man is 34. Okay, after you obtain the required answer, you can check whether your answer is correct or not by substituting the values that you obtained and compare with the information given in the word problem. So as you can see here, 30 plus 34 is 64. So it is true that the sum of the age of a man and his wife is 64. Okay, this is true. The other thing, the man is 4 years older than his wife. Clearly, 34, you can compare 34 and 30. There is a difference of 4. So our answer is correct. Okay, so this is a word problem leading to linear equations. Okay, let's add one more word problem, which is very similar to this kind of word problem. Thank you. So let's see the third example. So the third example says, 3 years ago, the sum of the age of a father and his son, was 52. Okay, it says 3 years ago, the sum of the age of a father and his son was 52. Now the father is 18 years older than his son. What is the present age of his son? What is the present age of his son? Okay. The third example is very similar to the second example. It's all about the age of two peoples, right? So to find the answer for this question, the first thing that you need to do is understand the problem, and you need to be able to convert these word problem into mathematical equations so that you can understand and you can interpret the problem. Okay, so as we did in the second example, let us try to give variables for the age of the father and the son. So let F be the present age of the father, and say S be the present age of his son. Okay, this is the first thing that you need to do. You need to represent a symbol for the variables or for the unknown things in the word problem. Okay, here we give a variable, f for the present age of the father, and s is the present age of his son. Now we go back to the word problem. It says 3 years ago. Okay, what do you do to calculate your age 3 years ago? You subtract 3, right? So 3 years ago, the age of the father is f minus 3, and the age of his son is also s minus 3. You subtract 3 from your age if you want to know your age 3 years back. Okay, now it says 3 years ago, the sum of the age of the father and his son. Okay, 3 years ago, these two will be, the sum of these two will be 52. Okay, so you need to add these two and equate with 52. Okay, now we have one equation containing two variables, right? You cannot find the solution for an equation containing two variables and one equation. So we need to have one more equation containing two variables, right? So this is an equation that represents the first statement, right? Then after, now the father is 18 years older than his son. So how do you represent this statement mathematically? If the father is 18 years older than his son, you have f, which refers to the age of the father. You have s, which refers to the age of his son. Since the father is 18 years older than his son, you need to write f is equal to s plus 18. Okay, now we have two equations containing two variables. One equation, this one, and the other equation, this one, right? Okay, so rewriting the first equation, we get f plus s minus 3, and minus 3 is minus 6, is equal to 52. And the second equation is f is equals to s plus 18, right? Now you can substitute f in this equation, right? In place of f, you can substitute s plus 18. They are the same. So substitute s plus 18 in place of f here. You have plus s minus 6 is equals to 52. Okay? Now collecting like terms, we have s. So it becomes 2s. So s and s is 2s plus 18 and minus 6 is positive 12, right? 2s plus positive 12 is equals to 52. Okay? Now take this plus 12 to the right side, or subtract minus 12, or subtract 12 on both sides. Then this equation becomes 2 times s is equals to 40. Okay? The last step is dividing both sides by 2. Then dividing both sides by 2 gives us s is equals to 40 over 2, which is 20. Okay? Now, the value of s is 20. And s refers to the present age of his son. So the question is, what is the present age of his son? This is the required answer. So currently, the age of his son is 20. That means by now the age of his father is 38. Okay? So you can check that 3 years ago, the age of his son is 17, and you need to subtract 3 from his father. His father is 35. You can check that 35 plus 17 should give us 52, right? So you can check this way. The other thing, there is a difference of 18 between 20 and 38. That is also another way of verifying the answer, right? So this is how you solve word problems leading to linear equation. Okay? Good. So let's add one more. So let's add one more example regarding this topic, and that will be the end of the lesson for today. Example 4. Example 4. The sum of three consecutive natural number is 33. What is the value of the largest number? Okay, here we have three consecutive natural numbers whose sum is 33. The question here is, we are asked to find the value of the largest of these three consecutive natural numbers. So to answer this, as we did for the previous examples, the first thing that you need to do is convert this word problem into mathematical equation. Okay, so let's say the first natural number is x. Let x be the first natural number. Okay, if x is the first natural number, since the numbers are consecutive, the next natural number will be x plus 1, and the third one is x plus 2. Because there is 1 difference between the consecutive natural numbers. So this is the first step. We are able to represent the unknowns by these variables. The next step is you need to convert this thing into mathematical equation. It says the sum of these three consecutive natural number is 33. So it becomes x plus 1 plus x plus 2 is 33, right? Then after, we collect like terms. So our like terms are x, x, x. So how many x's do we have here? We have 3x plus we have 1 plus 2, which is 3. The result gives us 33. Now subtract both sides 3 or take this to the right. Then this equation becomes 3x is equals to 33 minus 3. So 3x becomes 30, okay? Lastly, you need to divide both sides by 3, okay? Divide both sides by 3. Then x becomes 30 over 3, which is 10. So this x value is the first natural number, okay? The question is the largest of these three. So the largest one is this one, okay? The middle one is 11 because you will add 1 on 10. And the third one is 12. So the largest value of these three consecutive natural number is 12, okay? Therefore, the largest number is 12. So you can have different word problems leading to linear equations and inequalities. So the main thing that you need to do is you need to be able to convert the word problem into mathematical equations or inequalities and use appropriate methods of solving the equations or the inequality. Today, we have seen different things regarding applications of linear equations and inequalities. We have seen different word problems leading to linear equations and inequalities. I hope you understood how the problems can be solved. I believe that you enjoyed the lesson. Thank you for listening. Bye-bye.